For removing elements from a linked list, you use list delete, and it only deletes the entry from the linked list, so it just removes it from the linked list, but it does not free up memory, because freeing up memory means that you are actually deleting the actual data that is in that node, while list delete doesn't do that. It just removes it from the linked list. And this is how list delete is implemented. So you have the basically list delete that deletes entry from the list. You pass to it entry, the entry that you want to delete basically, and what it does, that it basically points the previous to the next and the next to previous, I mean, and that's done over here. So it basically points the previous node to the next node, and the next node to the previous node, so that they know about each other, and then basically gets removed from the linked list. So, but freeing up memory is something that you need to take care of outside of this. So you need to be able to delete it in reality. This just removed your struct from there. And since these are all different structs with different memory addresses, then you can basically reference them still. Okay. One thing to note also here is that when you're doing the list delete, you have you have it pointing to something that's called list poison 1 and list poison 2, and I'm not going into the details, but if you want to know what list poison is, you can read through this. There are multiple other functionalities that are implemented in for linked lists. One of them is list move tail, and I mean, list move would move linked would move elements between two linked lists. For example, list move tail would actually point to where you're going to move it. List empty to empty a linked list to start basically clean it. List splice. There are multiple functions that are implemented, and you can basically see all of them in the list.h. One thing to note, for example, that list move is quite interesting, because you have a linked list of all you have, for example, if you have a linked list of threads that are in the waiting state, you would use list move, for example, to move the linked list from the waiting state to another state when you basically want to go from waiting, for example, to ready. So you would use something like list move.